Okay, good morning, everybody. Quick show of hands. Who's working on a multiplayer game or helping a studio work on a multiplayer game? Okay, pretty good crowd, pretty good crowd. Okay, and even if you're not right now, I think this will hopefully help you in other efforts in the future. I'm Serge Kanastoutis. I lead engineering for Gardens Interactive. Before this, I worked at Riot Games and Singularity 6, but spent most of my career in general tech. Today, I want to talk to you about how do you make a multiplayer game, specifically with a backend, and how do you do it without bogging down and dealing with all sorts of friction. My goal is that you get some ideas, both from the case studies and lessons learned I'll share along the way, but then also what we've done at Gardens. So let's jump in. So first, who is Gardens? We're a 50-person remote studio spread all across North America, no office. We get together twice a year just to see each other. We're working on a shared fantasy adventure. If you've played Dungeons & Dragons, you watch the Netflix show Delicious in Dungeon, you like how Miyazaki tells stories where growth comes reinterpreting the environment, not just defeating a monster, that's the emotional tone we're trying to go for. So let me give you an example of what that looks like in game. You're traveling with your friends. Everyone's getting hungry. The game notices that and nudges you through the forest to where there's a campfire where a group of strangers are cooking. Now you all have to decide, are you going to fight, or are you going to sit down and cook with them? Or maybe for fun, you just throw anchovies on the recipe and ruin it and run away. There's lots of different ideas we want to have with experimental multiplayer mechanics. Okay, so when I first started talking to the founders, this is about a year and a half ago, and they had really ambitious ideas, and I really wanted to understand what does chance encounters with strangers actually mean in terms of a gameplay, because if I don't understand that, then I'm not going to be able to build a team and make architectural decisions or figure out what to do. So they started talking and had all these different ideas. And I had to start writing things down because there's so many different ideas that they wanted to achieve. First, they wanted dynamic maps. You had to be able to get lost in this world, but still be able to travel with intention. So the worlds were being dynamically generated, but with a lot of intentionality and some handcrafted mix. And then that was how we created these chance encounters by strangers, by creating these dynamic maps that would push people towards each other. So wait, that's not just level design, that's complex matchmaking, and not your 5v5 queue up for a session type of matchmaking. This is continuous, this is contextual, and it's driven by exploration. Then they had big ideas for social systems. Our creative director was the lead designer for Journey and Sky, and he really loves nonverbal communication. Things like synchronized movement, shared gestures, bonding without chat was all very foundational to him. So I got to figure out how to do this. They want crafting and magic, not just to help drive more exploration and push you to see different parts of the world, but also just part of multiplayer verbs. How do we cast spells together? What are the different types of ways we can unlock parts of the map? Like, there's a lot of different ideas that they had. Then came progression. So you've got these encounters where you're deciding whether you fight or cooperate. And the game's not going to be fun if every time it's a fight or every time it's a cooperation. There had to be some stakes. What happens if you die? Like, do you reset, or what progression happens? So we had to figure out what the exact mix was of why you would keep playing this game. And this is going to be a live game. There's going to be special events. Our CEO worked on Blazeball, which is this crazy interesting game where they are having community vote on the rules of the game, and he wanted to do all sorts of like live events. The world had to feel dynamic, alive, and iterating. So I knew we needed a custom backend. There's no out-of-the-box solution that was going to make this thing work. But that's okay, because I've got a lot of experience with that, and that's why I think we can thrive. So why am I talking to you? Well, I'm kind of a strange mix. I learned assembly language on the Commodore 64, and then went and got an MBA. Throughout my talk, you'll kind of hear me talk as an executive and a product manager and geek out on the tech, and that's kind of who I am. I kind of jump in all different sort of languages. I started writing my first microservice in 1995, and if you've ever worked in Java, you've probably used some of my open source work. I contributed to Apache, to Commons IO and Commons Lang that's used in just about every Java project for decades. I feel like a lot of the time I talk to my engineers, they look at me like Grandpa Simpson. It's like, somebody, please explain the NAT table. Tell me when that DNS entry TTL expires. Can we please tune the packet size on the load balancer? And they said, we don't need to worry about that. Kubernetes does that for you, dude. Before I got into games, I spent a long time running a consulting practice where I helped companies like JP Morgan and Hotels.com keep their internet apps working. And then I started a SaaS business and a digital sports platform, worked with about 1,000 colleges in North America. But about 7.5 years ago, I jumped over into games. First, Riot Games, then Singularity 6, and now Gardens. All multiplayer, all very ambitious, all global. So if you're trying to figure out how to make fast iteration with a multiplayer game, yeah, I've been there. Okay, so you know a little bit about me. I want to make sure you understand what I mean by the term backend platform, because everybody kind of uses this to mean different things. Here's a simplified game architecture from my perspective. First, you got the game client, which is running on a PC, console, or mobile. And then you've got the game servers. I'm assuming, since we're at Unreal Fest, everyone's running Unreal game servers. Can I get a show of hands? Do people run on Unreal game servers? Couple, okay. Maybe that's why you're here to learn more about stuff. And then there's the backend platform. So this is where everything else fits that's outside of the game specifically. So it can be things from your login system, your social system, your player support, telemetry, matchmaking, persistence, basically everything that gets this game to fit together and work online. So the key insight I want to share and why I draw this is your game client and your game server are very frequently in the same language and in the same engine. The backend platform is a whole other beast. It's typically a different IDE, different language, different frameworks, different deployment processes. In fact, very often it is multiple extra languages, multiple additional deployment patterns. Coordinating all of that so that you have a game that can work and be updated with all those different pieces at the same time becomes really challenging. And if you're not careful, it becomes the bottleneck for why you can't iterate on your game. So when the founders came to me talking about their vision, I knew I could help, but I also knew we couldn't just have a clean architecture. I couldn't give them a standard playbook. They wanted to iterate on these really interesting multiplayer dynamics that hadn't been seen in other games. We were a VC-backed game studio. We were going to take big swings. We were at least going to have 1 or 2 game mechanics that players had never seen before. So we needed to be able to do something special to iterate really quickly and try those different game mechanics out. But first, I'm arriving at Gardens. I got to get going. I just wanted to put in place industry best practices and what can I use off the shelf to get this going. And it starts with the Epic way. Before we get into that, I want to talk about why I think this is really important and talk about the thesis for why we're trying to do this. So why I think this is so important is if you can do this, if you can iterate and play in your game more quickly, you're going to be able to discover why your game is worth playing. This thesis is going to be used throughout the talk to make sure we're grounded on why we're making decisions, where we're achieving what we're trying to do. And it's a very simple framework to just think about, like, is what we're doing actually useful as we do the engineering work? Okay, so now that you've seen this, I'm going to put off my executive hat and put on that product manager hat and start thinking about the customer. So I'm not the backend architect. I'm the product manager, and my customer is the developer. And I want a good experience for the developer. And usually that means fast. But first, let's just talk about how you make a developer happy. And it's kind of easy. You let them work in their favorite IDE, you give them Unreal Editor, and you buy them as many monitors as they want. How many people here will use at least 2 monitors at work? Oh, okay. How many people use at least 3 monitors at work? Okay, how many use 4 monitors at work? Okay, I was going to say you should try VR goggles. This is like... Okay, let's get back to the developer friction and walk through as a product manager, what am I trying to solve? So the developer starts making the game, and pretty soon, they want to see what it's like to play. Now, how do you do that with a multiplayer game? You could write AI bots, but that's a lot of work and often doesn't really capture what multiplayer interactions look like, and you end up not using them. So ultimately, it's about getting that build in somebody else's hands. This is where the friction starts. You got to get things set up in version control, you got to get a centralized build system, you got to deploy things to the cloud, and you got to distribute the game to everybody else that you want to test, whether it's like your dev team or other play testers. It's a lot of friction, takes a lot of work, it's hassle, but finally you can get that going. And then someone broke the build. So now nobody can play test until you fix things. And wouldn't you know it, a couple days later, that developer broke the build. And you've seen this. Their shoulder slump, their soul leaves their body, and they start muttering, "It worked on my machine." So they're opening up all these different log files. They got the backend log file over here. They got the server log over here. They don't know why crash reporting isn't working. They don't know what versions of everything are running, but they have to work through all of this. And then finally they get it fixed. And they get it working, and now everybody can start iterating on the game again. But the next problem is, oh, now we're going to change something on the back end, maybe a matchmaking change or some persistence. So now they've lost a couple more days. They're setting up a new IDE, learning a new deployment process, working in a language they're less familiar with. And that can just take days before they get set up. They're never going to be really happy about it, knowing a lot of game engineers, but it's something that they get over. And finally, after a couple days, they're able to make a change, and they get things working again. And now they can continue and get back to iterating on that game. What happens now, though, as the builds start to get bigger, the team starts to get bigger. People start focusing on velocity, and the priority of keeping that working build starts to go down. Especially once the builds start taking more than an hour or so, when somebody breaks the build, it's often done for the day. In fact, it could be multiple days. Okay, curious, how many people have had the build at their studio broken for like 2 or more days in a row? Yeah, and it sucks. This is like how game dev with multiplayer games grinds to a halt, because you've now gone days, and the worst thing that happens in the situation is all the devs start saying, "Works on my machine, push the change, mark it closed in Jira, go on to the next thing." So when that one thing that's broken in the game is fixed, now you've got all these untested things that got to start unearthing, and it can just compound. Okay, so here's what I was talking about the epic way. I was coming into Gardens. I wanted to put in place the best practices. If you are setting up an Unreal Studio, setting up to use Unreal at your studio, you absolutely should watch this. There is documentation on this. There was an Unreal Fails talk 12 months ago about this. It is perfect. And so I had a team of Unreal engineers arriving at Gardens, and I said, first thing is put in place the epic way. So we reorganized the project structure. We got UGS working. We set up Perforce roles. We took what they had as a build system and got it connected so the UGS was working with precompiled binaries. And we could actually walk. And we started to make changes, and people could iterate. Now, that is a great starting point. As I said, I've done Unreal Dev a couple times, so I'm going to twist this and be a little cute and say, I want to put in place the Serge way. And this is a lot of off-the-shelf tools that complement the epic way. It's not a replacement for the epic way, but it sits on top of it to make things a lot easier and just gets us going faster. This is what it looks like. First, Epic Game Store. Epic, I really appreciate you having me here, but I kind of want to tease you. Why is the Epic Game Store not in the epic way? It's like the last mile of how you get the game to the players. I would really suggest a hotfix to the epic way. But also, joking aside, what we also put in place was Tailscale. This is a zero trust VPN. It basically makes everybody at our remote studio look like they're on a LAN, and it gets access to a lot of dev environments and just gives a lot of flexibility. Docker is a standard way to run applications in the cloud. Runreal, Marwan is here. I have built build teams at Singularity 6 and Riot Games, and it is expensive and it is frustrating. And Runreal has been this amazing partner to just basically give me a build team in a box. They've got a great package solution and really great service. So they've been really invaluable to Gardens. Assembler, I know a lot of people don't do this, but I've never met an engineer who wants to manage a Perforce server. So like we outsourced that to Assembler, and they've been solid. When everybody got scanned a couple months ago for some security vulnerability, Assembler was right on top of it. And when issues happen with the instance, I don't have to worry about it. Assembler takes care of it. And then crash reporting. You got to know what happens when the game breaks. Symbolication is the stuff of nightmares for most engineers, but we finally got the symbol files working. It uploads correctly with the builds. And now we have the Serge way in place. And now we went from walking to running. So we're going. It's going pretty well, but the team was going to go from 25 to 50 people. Builds were getting slower. We were adding a lot to the game. And now builds were taking an hour, they're taking 2, builds started to break. And most importantly, I was just watching us change game mechanics exclusively on the game server. We weren't actually changing things in the backend. So we weren't really getting the full iteration and really not unlocking these multiplayer mechanics. It would kind of like work in Pi and just sort of simply work, but then we actually tested it. It had really no meaning, it didn't have a lasting change in terms of what the interactions were. So now is time to start iterating on something special, something new. So I went around and looked at what had I done at Riot, what had some colleagues done at Riot, what we'd done at Singularity 6, and used those to try to figure out, with the thesis, what did we have to try to build. And so I'm going to go through with the case studies and talk through some lessons learned along the way. These are different ways that other studios have approached this problem, and with that, it's going to then inform the Gardens approach. First, the Riot SDK. I'm going to do another plug for another Unreal Fest talk. 6 months ago, Danielle presented this Riot SDK progress. This is an SDK that connects to all the shared backend services at Riot. So as I was talking about with the backend platform, they have payments, login, matchmaking, social graph, Vivox, all sorts of different things, about 20 different services, all available. I think I got a screenshot of this. So it has an enormous amount of capabilities in the Riot SDK, and all the Riot games rely on this. I was really amazed because this is what I worked on when I was at Riot from 2018 to 2022, and they've taken it so much further. This was being built when we were going from 1 game shipped in 10 years to we ended up shipping 4 games in 1 year. So it was really challenging to iterate with this SDK and get all these features for Valorant, Legends of Runeterra, keep League from breaking, get Wild Rift out, and TFT. It was a lot of challenge. And so I got to look at how was the iteration actually happening. The way it works, it's a C++ SDK. It's a whole bunch of plugins. It's not too dissimilar from the Unreal way of thinking about plugins. So it handles threading, connection pooling, and it handles dependency. So whenever you write a specific feature, if it depends on other features, you can just rely on that. So you got a social graph, it can call to the account system to make sure you're still signed in and who you are. And what that unlocks is incredible local iteration capabilities. So you can run your microservice locally, you can make changes to your C++ plugin, and you can test it all really effectively. It allows this super fast iteration, and that was what was really exciting to me and what I really wanted to try to figure out. Could we do this, but at a bigger scale? And so these are what the pros and cons are we took away. The work is very modular, so it's like very easy to make distinct changes and not worry about breaking everything. And the dev is local, so you can do iterations in a matter of minutes. The con is, as I said, these are rather small scope. This is like, how do your key bindings work? Or how does that integration with Facebook login work? Or these kind of really small features, social graph kind of concepts. It's not a full multiplayer mechanic. So I look at this local iteration and want to take on that, but I want to figure out if we can do it bigger. And also, it's very hard to do end-to-end testing. Once you dump the SDK into an actual game, it was a lot of extra testing to actually see if it worked the way it was intended. Meanwhile, Legends of Runeterra took a very different approach. What they did is they gave their build team the green light to go crazy. Make a build system that did everything. It handled the game client, the game server, and the backend deployment, and let anybody on the team very easily make a new dev environment with that full deployment. So every single engineer could, with some simple clicks, spin up a whole new dev environment that had the game client, the game server, and the backend, all working for them effectively. What this did that was so exciting was it let anybody access how the game was working. So, and this is what it looked like. It was a drop down in the launcher. You could pick any of these different versions of the game. So not just engineers could make changes. You could have designers make tweaks to the balance. You could have QA testing a specific version. It was very easy to switch around and try different ways. And it just really made it accessible to everybody on the team. So the pros and cons, everyone can do the loop. And it also was cross-platform from the get-go. It was going to be a PC and mobile game. And so now it's very easy to test these changes across a ways of different platforms. The problem is we are no longer on local iteration. You had to push your build to the mega build system. It had to queue and get things deployed then to game servers and then the backend, and then finally download back to your client. This meant builds were slow and also expensive. At one point, the lead told me they had 200 environments that they're paying for. And cost is one thing, but it's the slowness of iteration where you got to try to compete with all these other teams that are making changes to really be able to iterate effectively. Okay, Singularity 6. Another very different approach. As you may notice from the previous two solutions, we said central tech team or build team, go at it. And what we ended up with really was a backend-centric, a build-centric approach to development. Singularity 6 said most of our development is happening in Unreal. So what can we do to make their experience better? And this is what our game tech director came up with. We hooked up the play-in editor that everyone uses in Unreal to connect to the backend. So now you could log in with a player account and it would load up information about the player. Palia is a cozy MMO and it just has a ton of information about the ton of data that's associated with the player. Here's a screenshot of the game. You can see inventories along the bottom. You got quests along the right side. You have relationships with all these NPCs. There's a ton of player data. And this is where most of our challenges came with iterating, because you had this quest data was corrupted. It didn't progress, or it no longer offered the suggestion to go talk to this NPC to move forward. And now, because it was hooked in with the back end, you could very easily get all that player data, work with it in the Unreal editor. Now you're working with the blueprints and C++ to make changes to the game, connected to the backend, connected to real data. But it was such a simple solution, and it just really got us to appreciate, get us using the tools that the devs actually want to use to get rid of some of the friction. So we're back to local editing again. Devs are changing blueprints, C++ on their machine, making those iterations, reconnecting to the backend. It was really kind of fast, and it was really simple, but most importantly, using their tools that they wanted to use. The cons was the backend environment was a scarce resource and was very hard to change. We had 70 engineers at one point, and they were competing for a limited number of dev environments. So one team would come in, they'd try to change the backend, and then we swap back out to the most recent version. It was difficult, and it was very hard, and it ultimately didn't really solve that you couldn't iterate with the backend and the game at the same time. We did have amazing tools, so like if a player support reported some corrupted player data, we could grab from the live database into the dev environment, and now you could run in Pi and fix things. So it was great for certain situations that you're trying to develop, but not building something new. Okay, let's come back to the thesis. The more often you can play and iterate on your game, the more likely you are to discover what makes it worth playing. And so from these case studies, we came away with 4 key goals we wanted to have. I wanted local development. I wanted you to be able to iterate on the whole stack locally. I wanted to use existing tools as much as possible. I didn't want to have to introduce a bunch of new tech that they had to learn, because that introduced friction. I wanted to support many types of changes, not just like a modular key binding change or not just a debugging case, as many types of cases as possible. And I wanted easy access. I wanted to allow many people in the studio without a lot of technical skill to be able to work with it. So we got to work. We tried to create that local dev environment. I went to the backend team, say it is really hard to stand up the backend environment on a person's computer. And to their credit, they leaned in and they went at it. They recreated the full backend locally. One thing we did was we focused on simplicity over accuracy. When you're running thousands of game servers, there's a lot of orchestration and deployment patterns that require a lot of complexity that we removed for this. So we would just be running the application locally without a lot of the abstraction and horizontal scaling tech parts. We even built a CLI. It was like a cursive style, think like an old school terminal UI that would just, we put that executable in Perforce, so any game engineer could just click the executable in Perforce, run a terminal window, and then boom, they could see the backend start, they could see the game server start, they could see the last couple log files. It wasn't a huge investment, but it was trying to make this run locally. Almost immediately, we were excited. We got a huge win. Lexi is an amazing game engineer, one of our co-founders. He was facing this crazy bug that had been frustrating him for over a week. Turns out, with the dynamic maps, sometimes when they started, they would get hung, and then they would restart, and you couldn't really figure out what's going on. Turns out, there's a race condition going on. So as the different threads were trying to create the dynamic map, it would get in a state where it was assuming the other thread had completed, and it would just sort of sit there, and game servers would just freeze. He tried to recreate this locally for over a week. He couldn't. It was really frustrating to him. These are dynamic maps controlled by the backend and our matchmaking, and he just couldn't figure out how to repro it. So we said, hey, we got this new tool. Let's install everything locally. And suddenly he could recreate it. And once more, he wasn't iterating for hours, he wasn't wasting hours for a change to happen and then remember to see how it deployed. He could make a change within 5 minutes and see if it worked or not. This means he was able to fix this in 2 hours. And some of that is not just the iteration speed, it's the context switching. If you're able to make a change and see it in 5 to 10 minutes, you remember what you're changing, you know the theory you're trying to do, you're able to make more experimental changes, you're able to fix it. And it was just tremendously exciting. Lexi said there's no way we could have fixed this without this tool. He wasn't sure if we'd ever been able to fix it with the old deploy to the cloud, figure out what's going on, and understand what this race condition is. So we were pumped. This was exciting. We had this huge change, the co-founders on board. Let's go take it to all the engineers. Okay, so we got local development working. Let's talk about leveraging existing tools. And this is where we stumbled, frankly. So this is a run-through of what a lot of the tools that the backend engineers had automated. So it was all running on the person's computer and really easy to do. Lexi had benefited from it. We rolled this out in the meeting, and one of the game engineers, very polite, was like, cool, now all we need is this in the Unreal editor, so I don't have to deal with terminal windows. I remember this because I looked at the backend engineer on the call, and he just turned into sad Keanu. Game engineers don't want to work in terminal windows. Backend engineers would love to have tons of terminal windows, but not the game engineers. So we failed. But at the same time, when a customer tells you exactly what they want, that's great. So we regrouped and said, OK, back to the drawing board. How do we take what we built on the back end and put it into the Unreal editor? So play in editor. This is what people use, simulates the client and server locally. We want to figure out how to make that better, how to support the full stack. And so this is where one of the main functions of a product manager is to ask questions like, how do you make pie better? And the answer is, you put ice cream on top. So we made a product called Alamode. This was going to be how we ran the whole product, the whole game stack locally on your computer based in the Unreal editor. And we put it right in the toolbar in the Unreal editor. Pie, the normal play button, is on the left, and we added 2 options on the right to run Alamode, and I'll go through what those 2 buttons do. Here's what it looks like when you first run Alamode. You got a normal gym map on the left in your Unreal editor, and the big new thing is a control panel in the top right that I'll go through in a little bit more detail later. You can see game servers and backend logs spinning up, and a game client running in the middle of the game. Now you have everything running locally, you have the full stack, and it's all controlled by the Unreal editor. Here's what it looks like from an architectural perspective. Unreal, we've introduced a new C++ plugin that is the Alamode plugin, and when you click to run it, it spins up Docker Compose, and it runs a simplified version of our architecture. So you got the backend microservices, telemetry, the database, everything running locally. It then also spins up 1 or more game servers locally. I'll talk more about why it's really helpful to have multiple game servers. And then it'll spin up the game client, an uncooked game client, so it can launch within a matter of a couple minutes. And we're also going to add support for Pi, so it's even faster iteration. OK, so now we're using the right local tools. We have this all working locally to develop. Now we get to the hard part of figuring out many types of changes. This is what the control panel looks like. It just takes a couple minutes to spin up the whole game architecture locally. Now say you want to make sure everything's running. You just look at where it is. It shows you the backends on the left, the clients on the right, and then it shows the game servers along the bottom. It even shows the map, as we use a lot of different maps for our different game servers. This is all useful information for us. Now, say you're iterating and you change a game mechanic and you want to restart the game client, or you're changing how the dynamic map works, so you want to restart one of the game servers, or you've changed a microservice. You can just click the button, and really quickly you can iterate based on what you need without having to restart a whole architecture, do a redeployment, any of that. Trying to figure out what went wrong, we have clicks to log files, and then one of my exciting things is that we have a click to the dashboard, which is our player support tool. So now all of the information that's available to our player support team or live operations is available right on your local computer. So local devs don't have to know SQL commands, they don't have to know DevOps scripts. All of that's available through a browser right on their machine. And here's where we added a bunch of settings to control how they may be working for a while at a time based on their general preference. First, the UI screenshot's a little outdated, but I'll walk through the 3 ways that you can run the backend. First is auto. This is for game engineers who are not expecting to make any changes to the backend. It just downloads the latest Docker files from the build system. It runs everything locally, and they're able to iterate with the game server and the game client with full matchmaking, everything running locally. It's pretty seamless for them. There's no extra hassle. Then there's reload. This is when you're changing the backend and the game server at the same time. When you change a microservice, potentially it's got to recompile the microservice, create a new SDK for the game server, drop that into the game, and recompile the game. It's a number of steps that you got to remember along the way, and reload handles that for you. And finally, there's a BYOB, bring your own backend. We got some backend engineers who are power users. They've got the environment that they want to set up. They want to run Alamode and just rely on their dev environment the way that they want. So we have these 3 different options based on how they want to work. Next, there's options for command line arguments. Maybe you're trying to test a shipping build. Maybe you're trying to capture some trace information. Whatever you're trying to do, you can pass in args to the client or the server. And then say you want to have special network settings or you want to sign in with specific users. We all do this out of the way. This is all about reducing friction for the devs. OK, let's talk about multiple game servers. So we have this persistent world. You're going to be frequently traveling from one game server to another. And that's very difficult to debug. But with this, you can now have multiple game servers running, and you can test whether matchmaking is sending players to the right game server. You can test whether information is being persisted effectively. Say their poison damage is ticking down, and you need it to freeze, and then once they appear on the new map, the tick starts happening again and taking damage. You can now test that all very effectively. We've even had some VFX artists and some tech artists build more dynamic transitions from one map to another, because while a static transition's easy to edit, we want to let them use information like, are they with their friends, or is somebody chasing them to affect what that transition looks like. So this is really powerful, and it handles a huge edge case that we were having with the game dev. OK, and then the live ops tooling. Like I said, we had the player support tool, so they don't have to know SQL or DevOps scripts or anything. They can simply sign in, see all the information. Maybe they got to reset some data. Maybe they got to load in some problematic data. They can do that all very effectively through our player support tool. And we also have a lot of live ops information to let you see more helpful details about what's going on in your system. This is really great for me as head of engineering, because now I can have us invest in tooling and have it work everywhere. I don't have to have one set of tools that maybe help you iterate as a developer, and then another set of tools to iterate, to understand how to see the holistic system. It's one investment, and now there's much bigger return because it's affecting more scenarios. Dockerized game servers. So very typically with Unreal, you're running Windows game clients and Linux game servers. Linux is much more affordable in the cloud. It's an important situation, and you would think the same C++ code would work on Windows and Linux the same. And then when you're running in Pi, you're running everything in Windows, so we never saw this, but we are starting to see this nightmare forest happening in our game. We are doing floating point calculations on our dynamic maps and it was getting the collision data different on the client and the server. So you would walk around and suddenly there was an invisible tree in front of you, or what looked like a tree was actually not there anymore. You could just move around. It was really frustrating our dev team. And it turns out, yeah, the way Linux and Windows compile floating point precision is different. It was just a configuration change in the end, but with Alamode, we're able to run Windows subsystem for Linux on your computer and run the game server Dockerized locally, and now we could actually recreate this issue very effectively. This was something where it is so hard to figure out why is collision data being calculated differently. We're not moving to Clang everywhere just yet. That's a huge project, but we can at least figure out the configuration setting to get this working right. Okay, we got local development. We have lots of different ways of working. We have it in the Unreal editor the way that our dev team wants. Let me talk to you about the last feature we're working on. We've got it functional right now, but there's still some progress to go. And that's easy access, because I want everybody on our studio using this. Okay, who's been to a LAN party? Yeah. Late nights, yelling across the table, maybe smashing a couple mice because that Quake game didn't go the way you wanted. It's one of the best ways to enjoy games for me. And I want that in our dev team, iterating that way. So I want to support letting one developer make a change locally, and within a matter of minutes, have a bunch of other people across the studio trying that out. So I'm going to build off of what we have, being able to run the whole game locally, and get somebody else to get a quick version of those changes. Fortunately, Tailscale makes this really easy. It looks to everybody at the studio like they're on the same LAN, even if one person is in Edmonton, one person's in LA, one person's in New York. From a network perspective, it's invisible. The way we're approaching this right now is we're using Perforce to share the changes. So rather than having to do this multi-gig build locally, cook it, transfer that over the network to somebody else, which can take minutes or longer, we're just having somebody shelve their change, and then you can have the other players just grab it out of Perforce. And so now you're talking about kilobytes, maybe a couple megabytes, super fast. And now they run Alamode in that second button, and they get this pop-up that shows what CL they're running and what CLs are currently running across the studio. And now you can connect and see, interact with them like it's the normal game. This is what it looks like technically. As I said, we're using Tailscale. We've added this heartbeat service. So every time you run the game in Alamode, it's sharing that you're running this with a specific change list. And then we have Perforce as how we're sharing what is happening, what version of the change you're having. So combine now the command line orgs I was showing you earlier with the ability to actually have true multiplayer iteration. Unreal Insights is really powerful. It's a great way to tell what's going on with your client and server and why performance is taking a hit. The problem is always getting the right data of when something went wrong. What we can now do is, with Alamode, you get a more faithful recreation of what the game is actually running. It's not a simulation through Pi, it's an actual separate game server with the backend, so everything is running more true to form. And now you can have other people connect to them. We had one issue where people were saying they were having desyncs on a specific tree on one of the game maps. It was really frustrating because that's what the reports would all come in, and then became kind of like lore within the studio that there's something magical about that tree. It turns out that it was just, at that point, you actually were on a hill and you could see a vistage, and there were distance calculations that were slowing everything down. But it's really hard to spot exactly what in these scenarios are happening. When with Alamode, we're able to run everything locally, have people connect, and the person on their own machine can capture that trace of when that desync is happening and see what's happening and actually fix it in a way that normally it's very, well, I think this should help, or I think this is what's going wrong. You can actually get really solid data about what's happening. And so we're there. We've got some rapid iteration for the developer. We've hit all our 4 goals. So what's next? Most of all, I want a good game. I mean, this is what we're all for, is we're trying to iterate. All of these investments are to help us iterate and figure out why our game is worth doing. You guys have liked the concept art in the slides, I figure? So this isn't concept art. This is a screenshot of the game. It looks amazing. Lexi and our art team has done amazing work, customized the Unreal rendering pipeline. the art is where we really want it to be. But we still have to iterate on the design. We have to figure out why all these progression and multiplayer verbs work to make this really a fun experience. But specifically for Alamode, I want to prove the LAN party. It's functional, it's something engineers can use, but it doesn't really achieve what I want in terms of letting like a tech designer or an environment artist be able to make change and see how things work. Also, I spent a lot of time on quality of life improvements. Every week I look at our usage reports, I see who's using Alamode, who isn't, and go figure out why. Sometimes it's really something simple like Docker is taking too slow for new users and they just sort of give up and they don't finish getting the backend loaded. These are like really simple issues that like with investigation, it's going to just cause it to snowball. And with every person I get converted to a user, a believer of Alamode, it just makes iteration faster across the studio. And finally, I'm really interested in art use cases. Like a lot of what I've talked about are really engineering or design-centric changes. I would love to figure out what art can do with this. Because a lot of times artists are putting assets in the game and it's only in like the next daily build that you can really see what that landmark looks like or what that tree looks like. They're always working with like simulated versions of what's going on. I don't think this is a replacement for the art pipeline, but that's an area I really want to explore. So I hope you got some great ideas out of this. I have case studies in this link. I'm going to share the slides around later on. Maybe something we did at RIDE or Singularity 6 can inspire you or excited about what we're doing at Gardens. But yeah, I hope you all can help speed up game dev. Any questions?